Good afternoon. My name is Carrie Snyder, and I'm a Transportation Planning Director with ICF and part of the consultant team leading this research, along with High Street Consulting and Applied Pavement Technologies on effective methods for setting transportation performance targets. I'm joined today by my ICF colleagues, Sunil Duri, as well as Haley Eggert and Sarah Lettuce, who will be providing technical support, and DOT panelists, Andrea White from Iowa DOT, Simona Bobinciano, and Sanhita Lahiri from Virginia DOT. Today's workshop is the second in a series of 6 web-based workshops, the purpose of which are to raise awareness of the results of this research effort, which is a guidebook on effective methods for setting transportation performance targets, provide useful information to help transportation practitioners understand the effective methods for setting transportation targets, performance targets, how to implement these methods, and what issues to consider in selecting a method. And it's also to help transportation practitioners further engage on dialogue on target setting methods to learn from the results of this study and from each other. The focus of this workshop is target setting methods for travel time and freight reliability measures. And before we get started, I'd like to note that this webinar will be recorded and to make sure that everyone is able to navigate the Zoom platform. After each of our DOT speakers and at the end of the workshop, there will be time for questions. And we are hoping that this will be an interactive discussion. As questions come up during these Q&A sessions, you can drop them in the chat and we could read them to the panelists for answers, or you can use the raise your hand feature. And when you raise your hand, one of the facilitators will give you the ability to unmute and ask your question and have the conversation directly. And with that, I will turn it over to Sunil. You're on mute, Sunil.
Thanks, Kerry. I did not realize that. Hi, everyone. I'm Sunil Dhuri. I work at ICF and led the System Performance PM3 target setting part of the project. Let me start with a brief overview and purpose of the guidebook, and then we'll focus on the quantitative methods used for reliability target setting. As you know, for TPM, each state DOT, in coordination with the MPOs in the region, are required to establish publicly report the near-term targets for the national performance measures that were set by Federal Highway Administration. These targets can establish using quantitative, qualitative, or combination of these methods. Establishing of these targets present a number of challenges for state DOTs and MPOs. The objective of the NCHRP 2307 study was to develop a guidebook, a practitioner-ready guidebook with a menu of target setting methods for TPM. This guidebook is designed to help state DOTs and MPOs to identify effective target setting methods for setting the performance measures for the national performance measures. Today, I'll be focusing on target setting methods for travel time reliability and freight reliability performance measures. The guidebook, which is currently under review by the NCHRP panel, is organized in 3 parts. The part 1 of the guidebook provides an overview of target setting methods and considerations associated with target setting. It describes the target setting philosophies and discusses the range of sophistication in methods, challenges in target setting, and elements of effective methods. Part 2 of the guidebook provides a menu of target setting methods that practitioners can consider for specific individual performance measures. And these performance measures are across safety, infrastructure conditions, reliability, and traffic condition. Part 3 of the guidebook includes a discussion of performance measures beyond the federal requirement. It explores the reason for using other performance measures that goes beyond the federal performance measures, required measures. It also provides some examples of measures and targets. It discusses 5 performance areas the accessibility, greenhouse gas emissions, active transportation, transit ridership, and customer satisfaction. So the guidebook identifies methods for each of the national performance measures. The methods are either qualitative methods like the policy-based method that I'm sharing on the screen, or more of the quantitative methods, either performing historical trend analysis, probabilistic or risk-based approaches, or use of a statistical model or a sophisticated different kind of a model for target setting. The guidebook also addresses various target setting philosophies an agency could consider. Um, though data availability, data quality, and access to resources and access to tools are often the factors that an agency considers for establishing targets. The philosophy of the staff and the leaders also has a key part in establishing the how the targets are set. On this part, the philosophies that are discussed in the guidebook are either a state DOT or a MPO, the agency basically could have a conservative approach of target setting, uh, which the agency can attain the targets that can be attained easily. Uh, the agency can also choose to have realistic or predictive targets that reflect what is attainable in the stated time frame and be established in relation to the performance level that data indicates. An agency can also choose to have aspirational targets to reflect agency's aspirations and commitment to seeing improved outcomes. Uh, the guidebook also discusses about what makes a target setting method effective, even though it's difficult to say uh, what entails for a method to become successful, especially because this current established practice of standardized performance measures and reporting has been around for just a few years. Uh, Even with that, there are certain characteristics of a method which contribute to its effectiveness. Ease of application being one. Method that require less staff resources or technical resources are viewed as easy to apply. That leaves some time for the staff to analyze strategies and focus their energies on analyzing strategies rather than the application of the method itself. The uh, the other characteristic is technical robustness. Uh, Methods that account for different factors and looking at the data from different aspects and looking at data clearly using robust technical methods is another characteristics. The ease of communication is also an important characteristic while selecting a method. Uh, so any results that target are easy to understand. If the method itself is easy to understand, the target set using these methods would be easy to understand as well. So that's the philosophy behind selecting a method which is easy to communicate. Uh, Allowing for a policy considerations is another characteristics where if a method allows you to accommodate the policy considerations during the target setting phase, that would make a method more effective. Today, we'll be focusing on target setting and travel time reliability, target setting for the travel time reliability and freight performance measures. There are two travel time reliability and one reliability performance measure, freight reliability performance measure. The travel time reliability performance measure is based on metric of level of travel time reliability, often known as LOTTR. The freight reliability performance measure is based on metric truck travel time reliability index TTTR. The metrics are computed on each segment for the appropriate time periods per the performance measures. It is important to note that the travel time reliability measure uses a threshold to determine the reliability of a segment. A segment must have a LOTTR less than 1.5 for all 4 time periods in order to be considered reliable. While the important consideration for freight reliability is higher the TTRI index, uh, it signifies the worse reliability. The guidebook covers 6 primary methods for reliability performance measures. The guidebook covers a range of these methods, starting from a simpler implementation of these methods, which are easy to communicate. Also, on the other range of the spectrum, there are methods which are heavy, data heavy, and are resource intensive. The table on the screen summarizes the strengths and limitations of this and the other considerations related to these methods. So it may be a little difficult to read here. We have a table similar to this in the guidebook. In the next couple of slides, I'll be giving a very high level overview of these methods. The first method for reliability performance measure target setting is building off of baseline with assumptions. So this method basically pivots off the baseline value with some assumptions, either to maintain the baseline level or to adjust uh, the target based on any considerations or factors that might affect the future performance. The second method that I have on the screen, I have an example from Oklahoma DOT. We worked with Oklahoma DOT on the pilot phase of this project, and so this particular example is about performing time series analysis on the data. So it's a simple method that can be used for forecasting travel time reliability. Plotting the historic data on a chart helps us spot different patterns and trends. The example here basically shows you the different trends during before COVID, during COVID, and after COVID. Uh, the third method, I have is trend plus other factors method. This method takes the time series trend analysis method a little further. In addition to the trend analysis of the performance measure itself, the the idea is to gather information on external influencing factors. Examples could be VMT, population, employment, GDP, investment in roadway projects, etc. The trend observed in the forecasted external factors is used to adjust the performance of the performance measure itself. The example I have is from Utah DOT, where you would see that there is a clear inverse relation between VMT and the performance measure for interstate reliability. The fourth method the guidebook covers is the performance risk analysis method. It's a risk-based approach which takes into consideration statistical analysis to consider the possible ranges and variability in performance levels. This method is flexible. So the example I have here on the screen, it's a simpler interpretation of this method. So for Minnesota DOT during the pilot phase of this project, we used the box and whisker plot for the interstate travel time reliability measure to monitor the variability in performance levels across the years. Andrea from Iowa DOT today has a example of application of this method. They are using a more intense way of applying this method. They are using a specific software for risk analysis, and she'll be covering that in the presentation today. Another method that the guidebook covers is the segment risk analysis method. Again, this is a analysis method which is applied on an individual segment level. So this method's central idea is to look for segments which are at a likely risk to shift from reliable to unreliable or reliable to unreliable. So this method is little flexible and allows for development of different scenarios. I have an example from Minnesota DOT on the screen where they were monitoring different scenarios in terms of how reliability, or how the reliability of the segments would change in different scenarios, whether there are segments that are at risk of changing or from reliable to unreliable or unreliable to reliable for a future scenario. Another method that the guidebook covers is the statistical modeling approach. By a model, we refer to a formal setting of quantitatively forecast performance using sophisticated methods which go beyond the trend analysis. These methods could employ a variety of approaches, such as linear multivariate regression, logarithmic trend analysis, integrated least square methods, etc. Uh, Today, Sanhita and Simona from Virginia DOT will be talking about how they applied machine learning algorithms for travel time reliability target setting. Okay. So we have two presentations after this. One presentation from Iowa DOT. Andrea will be talking about how the methods that they have used for travel time reliability and freight reliability. And then we have a presentation from Sahita and Simona from Virginia DOT. They'll be talking about their application of methods for travel time reliability target setting approach. Before we go to the presentations part, the two presentations, we have a poll question that we'll share on the screen.
Thanks, Sunil. We'll give the attendees a few minutes to answer this first question. We'll post the results and then move to the next question before moving on to the presenters. All right, it looks like participation starting to trail off, Sarah, so we can show the results. So we've got about half of the respondents using the building off baseline with assumptions. And so I'm hoping that as we move through these presentations and the discussion, this is intended to be interactive. And so hopefully, especially at the end, when we have a more general discussion, DOTs can share more about why they chose the methods that they chose. Next poll question. So the first one was, what approaches do you use? This is more about what approaches are you interested in learning about? And I will say for each of these methods, the guidebook, which as Sunil mentioned, is still under review by the panel, we have developed these fact sheets for each method that has that, kind of what it is, how to do it, what data you need, and then includes examples of how DOTs have implemented these methods. So this is great. There's a lot of interest in some of these other more complex methods, which is great because Andrea will be presenting on the methods that include performance risk analysis, and Sanhita and Simona will be presenting on machine learning, which is one of the examples that we use as far as part of the statistical model. And so with that, we can move on to Andrea White from Iowa DOT.
Thanks, Carrie. As the slides come up here, I'm Andrea White. I'm the statewide planning coordinator with Iowa DOT. I'm housed in our systems planning office. My primary responsibilities relate to our long-range plan and our asset management plan, and I also get to play a role in our federally required performance measures. So that's what I'm here to talk about today. Certainly a very timely webinar. I hope we're not the only state in the position where we're still kind of early on in our target setting for the next performance period and figuring out what targets we'll be submitting by October 1st this year. So definitely a good discussion to have today. If you want to go to the next slide. So this just gives you an idea of what I'm going to cover today. A little bit about our overall federal highway target setting approach as we try to be somewhat consistent across the different metrics that are required for us to set targets for. I will talk through our initial PM3 target setting, as well as our 4-year target adjustments that we made. And then kind of try to walk you through the data that we have for 2017 to 21 to kind of paint more of the picture, and then talk about lessons learned and moving forward. I'm seeing some items in the chat that folks have lost the slideshow. I don't know if you guys want me to pause. I can see them, but it looks like everyone else can't.
Stop sharing and then reshare. I think that should work.
Does everybody see the slides now?
Yes.
Okay, excellent. Look, you didn't miss much. It's just the title page and overview slides. So if you want to go ahead and go to the next one. So this tries to break down our framework for our general approach to federal highway targets. This really started before 2018 with our first iteration of safety targets a couple of years prior to that. But then we continued it in 2018 with the PM2 bridge and pavement condition targets, as well as the PM3 travel time reliability and freight targets. So our overall approach has been to take a risk-based approach to our target setting with an emphasis on being data-driven. The idea behind the risk-based was to be able to have the conversation with leadership, not just about the specific number that the target was being set at, but what was the likelihood that we would achieve that target. I think our leadership found that helpful in terms of considering the consequences of not meeting targets, which, you know, for these in particular is not terribly significant. It's more reporting if you don't meet your target, but there's also kind of the black mark of not meeting your target. So it's just something to add some more value to the conversation and be able to talk about what you think the likelihood you will make that particular target is. Also, we wanted to try to focus on the point that there's really a cone of uncertainty around target setting, and anything we do set as a target is just our best guess. It's not necessarily going to happen, obviously. So to carry out this risk-based target approach, the idea was to develop prediction intervals and focus on what is the probability of achieving the targets. We kind of had two different methods for doing this depending on how much data we had. On the left side, when we had more available history for the data, we started by developing a trend model. So we were able to do that with safety and bridges, because in both cases we had quite a bit of historical data. When we didn't have so much historical data, on the right side, we focused on what variability are we seeing in the data that we have, and then try to use that to help predict likely future outcomes. So that was the method we used for pavements, because we only had a few years of data in the format required for the new federal highway targets. And then for PM3, because we basically had 1 year of data. In all cases, when we've come to the point of deciding what prediction interval or confidence interval do we want to use, we've stuck consistently with 75%. Felt like that was a level our management has been comfortable with each time. It's not as conservative as it could be, so there's not a guarantee we'll make the targets, but in theory, if our data and models are right, 3 out of 4 times we would make the target. So that's been a level we've been using consistently since really our first target setting efforts prior to 2018. Go to the next slide. So this slide is to set the stage a little bit for what's happening in Iowa. The 2017 baselines for Iowa are shown in yellow. The chart shows the 50 states, all of their baselines. So you can see that Iowa is consistently very reliable for these metrics. I think we were in the top 3 for all 3 in the baseline. And looking at data over time, I think we've consistently always been in the top 10 every year. So not surprising. Guessing if you think of Iowa, you probably don't think traffic congestion right off the bat. But we didn't have much of a data history to go off of as we were developing our targets. So basically all we knew at the time we started developing targets was we have a reliable system. But that's about all we knew. So that gives you a sense for where we were at in 2017. Next slide. So having only that 1 year of data available, we didn't have a lot to work with in terms of what is the variability within our data set. I should mention here, we were primarily using the CAT Lab tool that was developed through the AASHTO Pooled Fund. We're a member of that and are continuing to use it as that transitions to a TSP. We did some internal analysis as well, but we were primarily working with the output from that tool. So what that gave us was our PM3 reports that we needed for the HPMS submittal. Then that also gives you the annual metric for your state, as well as the monthly metrics. So you see that in the table on the right. That was basically what we had to work with. So we decided to use the monthly variability that we were seeing as a proxy for annual variability, with the understanding that we would need to continue to revisit that assumption in future target setting efforts. So the way we did the targets, and we did the same thing for all 3 metrics. So I'm only showing the interstate metric on this one, but it was the same process for each. The tool we used was an Excel plugin. It's called At Risk software from Palisade. I think it's a pretty straightforward software package. I'm not the person who used it, so I can't really speak to the details of it. I just know it's the general tool for kind of a Monte Carlo or stochastic process simulation. So you can try different models to fit for your data to give you a sense of what outcomes you might expect in the future. So when we use this tool, I'm just going to read you off the description of how this process works so I don't goof up the explanation of it for you here. So the data were analyzed to seek a best fit theoretical distribution for each measure, and parameters of those distributions were estimated. The cumulative distribution properties of each distribution were used to derive the probabilistic or risk-based targets. So we used for the interstate metric, we used the percentage of reliable interstate person miles for each month in 2017. That's what you see on the right side of the screen. The standard deviation of those 12 months is calculated, which was 0.345. We assumed the output followed a normal distribution. This was a flawed assumption, as you will see later, but that was our assumption at the time with each of these data sets. So using those cumulative distribution properties that I mentioned a moment ago of a normal distribution helps us figure out how to calculate the target. So in this case, to be 75% confident in achieving the target, that would correspond to a multiplier of 0.67 of the standard deviation estimate. So the way the actual formula would work then is take our annual baseline of 100, you subtract that 0.67 multiplier times the standard deviation of 0.345, and that gives you 99.77, which is shown on the screen there. We decided to round down for our actual target, so we rounded it down to 99.5%, but that was how we did the targets for all 3. Don't think there's anything else on this slide. So I'm going to go to the next slide. So once we had a couple more years of data in 2020, we took another look at our analysis. At this point, we had 36 months of data, not just the annual data for 1 year. And we had some worse data in terms of reliability than we had in that initial year. So when we reconsidered the models, it became clear a normal distribution did not make sense for the interstate travel time reliability or the truck travel time reliability metrics. It did still work pretty well for the non-interstate NHS metrics, so we kept the normal distribution for that metric and ultimately did not need to change the 4-year target. But when we considered what model provided the best fit for the other 2 metrics, we wound up going with the triangular model, which you see on the left side of the screen for the interstate metric, and then a log normal model on the right side of the screen for the travel time reliability index. With the interstate metric, it makes a lot more sense to not use a normal distribution because you can't go above 100 with the interstate metric. So you have a pretty hard ceiling, and we quite often are pretty close to that ceiling or at that ceiling. So the triangular model made a lot more sense. And similarly with the truck travel time index, there's not a hard bottom or top per se. I mean, I suppose you can't go under 1, but we still have a pretty strong cluster right down around, just over 1.1. So that's why we went with the log normal there. I did put a website on the screen. So if you just Google Iowa DOT federal highway targets, we provide a little more explanation in memos that are on that website. We've got that info on there for all of our various targets. So feel free to check that out if you are interested. Next slide. So I want to just kind of walk through kind of what we've seen over the past 5 years and what we've learned about our process and where we think we're going moving forward. So this provides you our annual metrics for the 5 years, including the baseline and the first performance period. And then on the right, you can see our 2-year targets and our original and adjusted 4-year targets. So if you're looking at our performance during the performance period, I put in red the 2 targets that we missed for those 2-year targets. And then the 4-year targets, we made all of those. Looking at this in hindsight, we were way conservative with our targets. We were trying to do that data-driven approach, but we didn't introduce any room for error into it. In hindsight, I look at that 99.5% 2- and 4-year target, and it's like, why did we put 99.5%? It's very aggressive, but that's what we did at the time. Once we had that bad year of data and we realized kind of what a bad year can look like, that helped us with our reevaluation of the targets, and it changed those models and made it such that they recommended lower targets. Those numbers are still the 75% confidence values, but once we had 3 years of data, it kind of really changed the picture we were looking at. So outside of 2019, the other years were very consistent. You can see very consistently reliable across the other 4 years that we have data for. Next slide. So I have a slide with the data charted for each metric. This is, again, that output from the CatLab RIDIS Map 21 tool. What I'm showing here is the annual numbers each year as the solid gray bars, and then the monthly numbers as the orange line. You can see with the interstate data how 2019 dropped quite a bit for several of the months as well as the annual number. It looks a little dramatic, but when you look at the scale, you kind of remember we're talking about 98% and above reliability here. So based on this metric, it's still very reliable. One of the interesting things to me on this chart is a lot of other states I know with the pandemic really saw an improvement. I think you saw that in the slides Neil showed earlier with Oklahoma and Minnesota. You could see on their charts how their travel time really bumped up in 2020, or the reliability really bumped up in 2020. We had, we didn't have anywhere to go in terms of going up other than just recovering from 2019. But you can see that the monthly values got a lot closer to the annual value. So there was less variability across the months of the year. Everything was pretty consistently highly reliable throughout the pandemic. And you can see at the end of 2021 how that starts varying a little more again. If you go to the next slide. So this is the other interstate metric, the truck travel time reliability index. So it's kind of a flip of the previous chart because now higher on the chart is bad. Again, see the same kind of thing going on in 2019 where the monthly metrics kind of get out of whack and the overall metric is worse than our target was in 2019. The other years have been very consistent, down in the lower 1.1234 range. What I like about this chart is you can see the seasonal impact occurring of winter. If you look around the Januaries where that's labeled on the chart, you see a spike about every year, and that's not surprising. So certainly have big winter storms and just bad winter driving conditions that would slow all traffic and especially trucks down. So I like that that kind of shows up on this chart. Next slide. So this is the other metric, the non-interstate NHS metric, which we only had this at the 4-year target for. This kind of shows a very different pattern. We don't see the issues in 2019 that we saw with the other two metrics. We also do see something we didn't really see with the other metrics, which is you can kind of see a little bit of a trend over time. It's a little early to decide if we're going to try to switch to a trend-based approach or not. I'm a little reluctant to do that because we don't have a lot of room to go up on this scale. But it is interesting that this one shows a bit more of a trend than either of our other targets do. Next slide. So I want to talk a little bit about what happened in 2019 and why we saw the worst conditions for the interstate metrics than we did with the other years in our data set. So go to the next slide. This was one of the major reasons, particularly for the truck travel time reliability index. We had very significant natural disasters in the state. We had flooding on the eastern side of the state with the Mississippi River, but what really dominated the year was the flooding in western Iowa along the Missouri River. There was record snowfall that winter. Ground was very frozen, then everything melted very fast. Then there was a lot of rain on top of it, and it just overwhelmed levees throughout the basin and was quite a disaster, and not only in Iowa, but throughout parts of the Midwest. So portions of I-29, which basically parallels the river in western Iowa, were closed, in some cases up to 100 days across several time periods. You can see these photos are from March, June, and September. So this was kind of an ongoing event throughout the year and caused quite a bit of issues. So we saw the effects of this show up in our truck travel time reliability index measure. We didn't see it show up so much in our other two metrics, our travel time reliability metrics. I think the reason for that is because that threshold for those metrics that Neil mentioned earlier, that threshold, which is a 1.5 ratio, we were seeing higher ratios in this area, but it was still under 1.5. So they were still judged reliable for this particular metric. So they don't show up in the data I'm showing you today, but it was still certainly impacting all traffic in the area. Next slide. This is just to help visualize that truck travel time index. This is based on GIS skills I formed almost 20 years ago, so I apologize for the rudimentariness of the map, but it's just meant to show a quick visualization of the fact that I-29 in 2019 really jumped out on the truck travel time reliability index. Again, parsing that data out, I used 1.5 as a break. Obviously, this is a different metric than the interstate reliability metric, but it gives you a sense that even though it was pretty bad compared to other years, it was still under that 1.5 threshold for this particular metric and calculation. That just really helped us understand that, yes, that was a big part of our problem in 2019 with our annual performance. Next slide. Just another way that we tried to look at the data was to try to understand, so how much of our system is not reliable or was unreliable through 17 to 21. So what I'm showing here is the percent of the system's mileage, not the person miles, but mileage that has a reliability metric as defined by for that performance measure, that the metric is greater than or equal to 1.5. So you can see what a small percentage of the system that equates to on all three of these measures. Interstate reliability in particular, it's a very small portion of the system. Part of the reason that we looked into this was when we missed those two targets in 2019, we needed to kind of do a bit of a dive into the data and understand why. once we realized that the flooding was not the reason that we missed the interstate reliability target, we took a closer look at that metric in specific. I've since then looked at the whole 5 years to try to figure out, are we seeing systemic issues with the interstate over time, or what's causing us to have some issues on the interstate? Looking at that, we found that only 47 TMCs out of more than 1,000 have ever shown up as unreliable based on this metric. Only 12 of those 47 have shown up unreliable more than once. So in other words, there's not really systemic issues that we're seeing on the system. When we look at those 12, one of them is on I-235 in Des Moines, which is our busiest roadway in the state, a major commuter corridor. Certainly an area we know we have some operational issues, and we're working on solutions to those issues. 5 of the TMCs were near the site of this photo. This is the I-74 bridge. This was when it was under construction last year in the Quad Cities. This is a project that went on for several years and had lots of staging and traffic changes. And a lot of the reliability issues that we've seen in the last 3 years on the interstate system just relate to this area and dealing with this particular work zone. And then frankly, most of the rest of the TMCs we came across, especially from the earlier years of the data set, were actually ramps that shouldn't have been in the data. That's been a learning curve for us, kind of realizing some of the QA/QC we still need to do on the data we get out of that tool that we're using. And I think over time that will improve and we won't see those issues anymore. Next slide. So I'm going to walk through some lessons learned and next steps for these last 2 slides. So with our methodology that I talked through earlier, some pros and cons on using that type of methodology. It's pretty straightforward. It's, takes something like just a trend based or just carrying forward current values, just another step basically. But it's still pretty simple. It doesn't require a statistician. You can just use an Excel plugin like the one I mentioned. I'm sure there's other tools out there as well. We like that it's data driven. We like that we're not shifting to kind of a policy based, reducing or improving by a certain amount each year, or targeting a very specific number, or being aspirational either. And we like the risk-based component. Like I mentioned earlier, our management's been pretty satisfied with that 75% threshold. It's not so conservative that we'll never miss targets, because like I mentioned, we did miss 2 of them. But it gives us better than 50-50 odds because we're using that particular confidence interval. I included a few pros and cons regarding the MAP 21 tool as well. I'm sure there are some states that use it and some that don't on this call. On the pro side, it enables anyone basically to work with the data. You don't need to work with the actual raw data or be able to manipulate it in any way. So that's really handy. We really like that it's available to the state's MPOs if you're participating in this pooled fund, or now it's a TSP. That's something that was of value to us, because otherwise several of our MPOs probably would have been looking to us to help them with these metrics as well. So that saved us time there as well. Overall, it just saves us a lot of time and effort. It does cost money, of course, to participate. It varies by state depending on your mileage, but our cost has generally been like $30,000, $31,000 a year. So not cheap, but it's not ridiculously expensive either. It kind of lacks some customization. Something that we would have liked to have been able to have done is calculate the metric for different time periods. So maybe a rolling 12-month average, or maybe 3-month or 4-month periods, to kind of get some more sense of the variability that we could see depending on what time we're looking at with the calculation. So that's something we would like to be able to do in the future somehow. And then just still do have to review the data. Like I mentioned, we've started finding that there were some ramps, things miscoded in the data set, things that we needed to make sure we got corrected in future submittals. So that's something we continue to work to improve. In terms of the results that we've seen, as I mentioned at the beginning, Iowa is a super reliable state. So we haven't seen horrible results from any of these metrics in any of the years, but it did show in 2019 in particular how a major construction project can impact our metrics, as well as how natural disaster can impact our metrics. So that gives us more to think about moving into the next target setting in terms of, should we factor in more of a contingency for these types of things? Or if we know we have a major project in a particular area, perhaps we should factor in some buffer related to that. And so far, it seems like 2019 was an outlier. The other 4 years were all very consistent compared to that. So next slide. So moving forward, we will continue to review and try to improve that data that we're getting from the Max 21 tool to make sure it's as correct as it can be. Certainly interested in learning more from other states, so I'm hoping we'll hear some from those on the call today. I'm certainly looking forward to Virginia's presentation following me here. We're gonna consider, like I just mentioned, whether things like construction projects or natural disasters should be factored into how we set our targets, perhaps move away from a strictly data-driven approach to include some type of contingency. Over time, perhaps look at a trend-based methodology. I don't think we have enough data yet to really do that here, but over time, perhaps we will. And then finally, I know this has all been fairly surface level, and I haven't really talked about how we integrate the PM3 metrics into our planning process. And part of the reason for that is we primarily use other data, not NCHRP, and other, different buffer time index, different ways of looking at travel time reliability and speed, besides the PM3 metrics in our work. We do incorporate travel time reliability and speed data and such in our work, just not this federally required specific set of metrics per se. So with our recent long range plan, which was just improved in May, we had several layers of analysis, two of which would incorporate travel time data. And we currently are getting that from INRIX, so it's the same provider of the NCHRP, but we had an operations analysis that incorporated a buffer time index along with several other factors that impact operations on the corridor to give us a sense of where we have corridors most at risk from an operational perspective. And we also use that data for bottlenecks analysis to try to pinpoint the specific areas around the state that have the most delay throughout the year based on that travel time and speed data. We're currently working to integrate those analysis efforts, which are statewide, into our project prioritization and scoping tool, which is what project designers work in when they're developing a project. So when someone would start to design a project in one of those areas, it would tell them if it's flagged for these or several other analysis layers as part of the long range plan. So that's kind of our statewide planning effort. And then we certainly have project level things going on with reliability data that include several things like our work center performance measures. They do after accident reports where they look at the traffic effects that accidents had in the surrounding areas, reports on congestion, delay, corridor planning, et cetera. We're certainly using this type of data, just not necessarily the NCHRP and the PM3 metrics so much. So just wanted to close with that to kind of give you a sense of how we do incorporate the concept of reliability into our planning and project development process. So I think that is it. The last slide is just my email. So happy to address some questions now and then later on as well.
Thank you, Andrea. Sunil will be monitoring the chat for people putting questions in there. And I'd also like to invite the attendees. You can raise your hand and we can, what you'll do is we'll click allow to talk and it'll give you the option to unmute and ask any questions.
There is one question at this point from Alan Ward. What does Iowa DOT use? How does Iowa DOT use its PM3 targets in policy development and project selection decisions?
Yeah, so I think that really gets to that last point I was just making with the end of the presentation. I guess I saved that for the end. The PM3 targets themselves, I would not say are really informing decisions at this point. It's more of a monitoring thing in terms of looking at where we're at from this particular definition of reliability. But we're using the analysis I talked about with the long range plan, where we've defined some different ways to look at reliability at the corridor, and also at kind of the intersection with that bottleneck analysis. Look at it at those levels. So those analyses are getting incorporated into our project development process. But I wouldn't say these particular metrics or the NPM RDS are at this point. But that's something, we want to explore ways to make this target setting process more meaningful in that regard. But I don't think we're there at this point.
Thanks, Andrea. I don't see any other questions at this point.
No one has their hand raised at this time, so we can go ahead and move on to Virginia DOT's presentation, and then we can reopen the Q&A, and we can always go back and ask Andrea additional questions as needed.
All right, good afternoon. So today, my colleague Simona Babichanu and I, we are going to present to you Virginia's target setting methodology for MAP 21 interstate travel time reliability measure. Before we get started, I wanted to kind of stress that this methodology we present will be again for interstates. For the non-interstates, we have a separate ongoing effort that, and that method could be different from the method that we present today. Next slide, please. So this is a brief outline of our presentation today. We are going to talk about the metric and the measure, and then we kind of a little bit going to get into the detail of it, our understanding, etc., and then talk about the target setting and then open it up for questions. I kind of also wanted to add that our presentation today does not include the freight reliability measure. Slide, please. So Sunil already spoke to the requirement of this. I'm not going to repeat what he said, so I will just say skip the slide. Let's go to the next slide, please. All right, so again, Sunil also spoke to this, but I kind of wanted to make sure I made the point that the LOTTR threshold on which we are going to determine if a segment is reliable or not is really a binary threshold, yes or no. And as we go through the process, we'll find that that actually has an impact on it. For the next couple of slides, what I'm going to do is kind of lay out a little bit, one example to show how in Virginia, for example, this binary threshold might show up somewhat, how to put it, non-intuitively. Next slide, please. All right, so what you have here, can you maybe click twice? All right, good. And one, yep, keep that. Can you keep the, yeah, thank you. I should have taken the animation off, but anyway. So what I'm showing you here is an example on a interstate section on Virginia. It's I-66. I don't know if any of you are from that area, but it's notorious for its congestion. Let's just put it mildly. Now, what you see here is kind of an example of the 50th percentile speed, which is the TAN area, the 80th percentile speed, and sorry, the 20th percentile speed, and which is in perspective to the posted speed limit in that area. So on the top, that's what you see, those 20th percentile, 50th percentile speeds. On the bottom, what you see is the actual calculation of LOTTR. It is 80th over 50th travel time, so it is 50th over 20th speed. So the bottom shows this static threshold of 1.5, which is the entire green area. So if you are below 1.5, you are reliable, and if you're above 1.5, you're unreliable. So that little pink portion that you see that is peaking above the green is considered to be unreliable in this entire segment. Next slide, please. Maybe a couple of more times. Oh, back up one more. Thank you. Now, I kind of wanted to, once I've laid that, what is 20th, 50th, and and how they lay out from a speed point of view, you can see that the speed is going down. As you travel right, that is basically you're traveling eastbound. So as you're traveling eastbound, speed actually is going down. You're both your 20th and your 50th. And there is a congested condition. It's not just perceived, it's a felt congested condition where you are quite below the posted speed limit and people are really slowing down, right? So that is our congested condition. But if you take a look at the bottom graph, you will see that even though in reality people have hit congestion, and of course things need to be done for that condition of congestedness, it is still considered reliable. So on your left section, you see it's reliable. The only unreliable part is where the line of 20th percentile speed is farther away from the 50th percentile speed. So it's we all know how kind of ratios work, right? So but from an unreliability point of view, because how this is defined, only that little section shows up as unreliable segment. And onto the right is unreliable. We have low speeds, low average speeds. We have high travel times. It goes, actually, there are, it can be considered unreliable by some other metric, but based on this metric, it shows up as reliable. So we have started to call these sections reliably congested. This is just, I wanted to set this up so that we recognize as we go through the process of developing methodology for map 21 target setting and consider a variety of things. As we go through this, you'll see that we did. And then we kind of come up with one number statewide. In essence, it would be somewhat of a crystal ball as far as the map 21 target setting goes. So with that, next slide, please. All right, so now we will get into the actual target setting steps that we did. This slide kind of lays out the steps, and then I'm going to tag Simona, who will take us through the details of each of these steps. So first, we prepared the input data for a variety of variables. We developed a model for prediction. We validated that model and the measure. So we kind of a two-step validation process. And then we prepared a future year data because whatever the model was developed on was based on past data. So we developed a future year data. And then finally, we predicted a target for future years. Next slide, please. No, this is yours now.
Thank you very much, Sanjita. Can you hear me now?
Yes, we can.
Thank you very much. So my name is Simona Bobiciano, and I'm working with Sanjita in the Traffic Engineering Division at VDOT, and I will talk to you in the next few slides about our target setting steps. So the first step was input data preparation. As you can see, we tried to think of what are the potential influencers on travel time reliability on interstates, and we came up with these types of data grouped into 6 categories. The ones that are in bold and orange font are given to us by FHWA, and we brought the other data sets mainly from internal VDOT databases, but also from other sources. Next slide, please. Looking more into the data preparation, most of the time was spent into this data collection, preparation, and exploration phase, and not only from the input data preparation, but I guess from the entire target setting methodology. And you may have heard that 80% of a data scientist's time is spent on finding, cleaning, exploring, and organizing the data, and that was the case for us too. We had 5 years of past or historical data from 2017 to 2021, and 4 years of future data from 2022 to 2025. And we predicted reliability for all those 4 years, even though by FHWA mandates, we're only required to submit targets for 2023 and 2025. We did a lot of cleaning and conflation, visualization, exploration. So these are like a few examples of visualizations, all with the purpose of trying to establish variables. In other words, trying to see how we can code those influencers in our model. Next slide, please. So here we're looking at that, looking at the data. We try to see how the data looks like. We try to see how we can, if we can get insights into travel patterns, into trends in the data, and also if we can see if there are problems, issues, exceptions, and so on. So these are a few examples of issues that we found with the data. By no means this is everything. So for example, the fact that the network changed sometimes from year to year, it had discrepancies and inconsistencies, we had to deal with that. We also noticed as an example of data granularity and accuracy, the weather data that we use from the NOAA stations. We have only 29 such stations in Virginia, and some of the segments that were mapped using the NOAA stations might have been quite far away from where from the location of the weather data, where the weather data was collected. So maybe the weather data did not really accurately pinpoint the weather conditions at the location of each segment, but there's nothing, that's the data that we had. And the angular V chart here shows a plot of the 80th percentile travel time over the 50th percentile travel time, which are the percentiles that appear in the LOTTR. We notice very easily that the reliable segments plotted in gray have a much tighter dispersion than the unreliable segments plotted in red. So this kind of like showed to see that it is they are much easier to predict than the reliable segments are easier to predict than unreliable segments, which you will see later. Next slide, please. So after all this, we came up with a set of 30 variables in total that we used as inputs in our model. And I would want to draw your attention to the block on the bottom, the independent variables that are the traffic indicators, the event indicators, and the operational improvement programs, for which we established a variable for each of the 4 periods for which we have to calculate LOTTR. And also we tried different versions for each of these indicators and found that the best one that gives us the least error and is the best, gives us the best accuracy are the ones that sit here, volume occupancy ratio. We looked at the crashes, but the total number and the duration by for the incident, so measuring different things. Next slide, please. Step 2 of our target setting methodology was model development. And besides the input preparation, we also had to think of what is our model going to predict. And some of these are things that we try to do and end up we didn't in the end didn't work for us. And also we tried different types of models. So what I want to emphasize here is that this process was a long and laborious process, and it was a trial and error methodology. It didn't really work up from the very beginning. Next slide, please. Thank you. So after this process, at the end of the model development phase, we ended up on using the machine learning algorithm called random forest. The purpose of the goal of using the machine learning algorithm random forest was to predict whether a segment would be reliable or not in each year. So we predict yes, reliable, or no, unreliable. This goes back to the observation of the LOTTR greater or less than 1.5 then that Sangeeta mentioned at the beginning of our presentation. So the key feature here in the random forest model, and maybe in other machine learning models, is that we use the data to evaluate and refine the model. The more data we give to the model, the more high quality data we give to the model, the better the model is able to find and estimate trends and patterns in the data, and the better it is then able to predict accurate results for future data for which we are interested in. So we took the entire 5-year historical data set and we split it into training and reserve or test data. And with the training data, we gave that to the model and we said, this is our inputs and these are your outputs. So we gave both the inputs and the outputs. And we told the model, go ahead and find out how are the inputs connected to the outputs, find patterns, find trends. And then once they did that, we went through different phases to see which works best. We went back to the reserve data set, and then we gave the model the reserve data set from the historical data and said, okay, these are some new inputs that you have not seen here, give me your outputs. Then we got the outputs from the model and compared with the observed reliable or unreliable characteristic or attribute that we knew, and then calculated the accuracy of the model. And once this is done, and we're happy with this, we applied the model for the new data for the future data set. And predicted whether the segment in the future will be reliable or not. Thank you. So next slide, please. So this is an interesting insight that we gained from the model. So after running the model and refining the model, we saw that the input variables, the 30 input variables, sorted themselves somehow into 3 categories. The ones on the top, which are the volume and the track indicators, so the traffic influencers were deemed consistently the most significant variable in determining reliability. In the second tier were the events like crashes, weather event, and incidents, and the least significant ones were the rest of the variables. Next slide, please. Going to the third step of our target setting methodology, validation. As Sangeeta mentioned, we did a 2-step validation. So this step had 2 sub-steps. First of all, we validated the model itself. So remember, the model is predicting whether a specific segment will be reliable or not in a specific year. So we validated that. And then we did a second validation for the measure. So this slide talks about the model validation. Remember when we talked about the model itself, we said that we split the data into testing and training. So this only talks about the validation step that is performed on the testing data set. So we split the testing data set represented 30% of the entire historical data set that was randomly chosen between the years and the TMCs. And we calculated these accuracy numbers that are in the last 3 columns on the right. So the overall model accuracy is in the accuracy all segments column, and you see it varies between 93 and 96 or so %. So it's very high. We're pleased to see that. And looking at the accuracy of the reliable segment, that's called sensitivity, and the accuracy of the unreliable segments, that's the specificity column, we see that the sensitivity is significantly higher than the specificity. So it's for our model, it was much easier to predict. The accuracy was higher, and it was easier for the model to correctly predict when a segment was reliable, and not so easy to predict when the segment was unreliable. And if you look at the columns on the left, the first 2 columns represent the observed reliable segments, and the columns in the middle, the unreliable ones. So in Virginia, we have, as Andrea also noticed, many more segments that are reliable. So the sample size for unreliable is smaller, such that for the model, it is a little bit more difficult to find those patterns. That's why we have we have lower accuracy for the unreliable predictions than for reliable ones. Next one, please. The second step of the validation process was the measure validation itself. So we use this model as an intermediate step to actually be able to predict the MEP21 measure, PMTRIS, which is the Interstate Travel Time Reliability Measure. So the predicted PMTRIS numbers were obtained using the predictions of the model. So for each segment, we took what the model told us, is it reliable or not? And the actual PMTRIS numbers were obtained using actual numbers. These are the official, our official results. So the errors that we got by comparing the predicted and the actual values of the measures are, as you can see, very low. We're happy to see that. The highest one is in 2020, but still is less than 5%, sorry, 0.5%. And the lowest one was for last year, which is very, very low. So maybe could have been that last year in 2020, we had much higher reliability than for the other ones because of the pandemic. So maybe we did not really do anything special for the pandemic year or for the pandemic. So maybe the model got a little bit confused because it really didn't have that extra information about the pandemic. So after that, with these 2 accuracy levels calculated, we're happy with the results. So we went to the next step to try to apply the model for the future years. So go back to the next slide, please. Thank you very much. So this is going to be our next step, our 4th step in the target setting methodology, which is a future year data preparation. So we started with a number of lanes and went into the 6-year improvement project plan and looked for projects that were scheduled for completion between 2022 and 2025 for added capacity and extension of decel lanes in those years. And there is a little map and some statistics on those projects here on the slide. Next slide, please. So besides that, we had to prepare future year data for all those 30 variables. So besides the number of lanes, looking at the crashes. For crashes, we use a little more complicated method than for the rest of the variables, but we think it's a more accurate method. And we use the safety performance functions that were developed by our friends in the VDOT safety group. So those are power function models that use segment length and estimated future year AADT to calculate the total number of crashes irrespective of severity. So total number of crashes by TMC, by segment for each TMC in this case for each year. So to estimate the future AADT, we used a most recent AADT, which was 2021, to which we applied pre-pandemic growth factors. The sites that the safety performance functions use are characterized by number of lanes, urbanized characteristics, and internal, external, by which I mean internal are the ramp areas and external are between the ramps. and the model predicts the total number of crashes, daily crashes per year. The safety group uses a calibration step in which the predicted number of crashes and the observed number of crashes are made equal to make sure that there is some correspondence between them. So I did that as well. We calibrated the future number of crashes, and then because the model only predicts the daily 24-hour crashes, we had to separate these by those our AM peak, PM peak, and so on periods, and we applied some historical crash fractions to be able to obtain the crashes for the peak periods. Next slide, please. So the other ones, other influencers, the volume to capacity ratio, like I mentioned, ADT was obtained with growth factors by district, and the number of lanes from the future years based on the projects, and we used the HCM method. And for the other influencers, the weather and the incidents were taken at average of historical. The SSP coverage, terrain, urban categories, and I forgot to add here, but we need to add the network as well, were the latest available for the year 2021. So the network that we use for future years was the 2021 network. Next slide, please. So after that, we ran the model, and this is a visualization of the reliability status, reliable or unreliable, for all the 4 years. So this is cut here. Everything to the west of this is predicted as reliable. So it was cut out from the picture just to have a little bit more, to be able to see more clearly what's going on. And the areas of the red, the unreliable areas, are where actually most of our historical unreliable areas 2017 to 2021 were, in the urban areas around Northern Virginia, Fredericksburg, and going back into downtown Richmond and Hampton Roads area. Next slide, please. And these little blue boxes signify, just to point your attention to the fact that our model ended up showing a good sensitivity towards project improvement. So remember, we took those projects from the 6-year improvement plan. So for example, here, there is a large project that is slated to be completed in the Fredericksburg area on Interstate 95 in 2025. And you can see that the amount of red for 2025 in that area is smaller than for the other previous years before the project completion. So we see that number one, model is sensitive to projects, and number two, projects do have a positive impact on reliability, even if it's measured the way it is measured for MAP 21. So next slide, please. So here I'm going to hand it over back to Sangeeta, and thank you very much for your attention.
All right, thanks, Simona. So here, basically, after running all those models and for the future scenarios, what we come up with is basically kind of a 95th percentile confidence. What we have, what you see here, the purple at the top is your upper bound, the gray at the bottom is your lower bound, and the orange in the middle is your likely measure. What you, this, based on the output from the model for each year, the measure was calculated based on our original formula that FHWA gave us, and then they came up with the upper bound and lower bound. For purposes of accuracy, we can see. I mean, if you see on the left side, actually the range is very short range. So visually, this might look, the band might look a little big, but in reality, the band is very small. So, and we were very happy with that, which kind of shows a lot of agreement in the results. Next slide, please. All right, so what we did was, so that was basically, we predicted rather, measure for future years, but what is required is ultimately the target. So, and we have to make a recommendation for what that target number would be. And so for the purposes of making the recommendation so that our executives can make the decision on that, we kind of laid it out on your left-hand side. The bar charts actually show the actual measures in the first performance period, where the baseline was year 2017. The baseline for the next performance period is 2021. And this is where we are making the projections for. So the blue line, we kind of wanted to provide a range so that the executives can pull that number from that range. The blue line was the 95th percentile confidence interval with capacity improvement projects completed. As Simona mentioned, we considered the 6-year improvement projects. So this is the most optimistic prediction. And the bottom orange is if, say, something happened, some projects didn't finish on time or things like that. So it is the least optimistic, which is the lower bound without any projects getting completed. Even then, we can see that the range is, that the bandwidth is not very large. So this is what we provided to our decision maker executives, so they know how the trend looks like. We have to predict for, we have to provide targets for 2023 and 2025 in the next performance period. And so we have made our recommendations to the executives to take the lower bound. Now it is their decision to make. While we were running the statewide model, we were also, since we knew which segment belonged to what MPO, we were able to also kind of run some the models in a smaller area for each MPO and predict measure. Next slide, please. So this is what the MPO-wide would look like for 2022, 23, 24, and 25. MPOs can, use this, or they can develop their own targets. They have the full authority to do that. Next slide, please. All right, so to summarize, what did we find after all this effort was done? That the random forest machine learning algorithm can be used. So we found, because as Simona mentioned, that we went through a lot of things, trial and errors, before we actually landed on machine learning. So, but we found that to be somewhat stable and useful for this purposes. The independent variables can be influenced by factors not in our control. So that's the crystal ball I was talking about a little bit. Not just because we have a threshold-based metric and that threshold is static, but also there are other things that really is not in our control, like unexpected change in growth due to land use change, redefining of urban category based on census results, change in travel pattern due to pandemic impact. So the pandemic impact is not yet said and done, honestly, on the travel changes. So travel patterns are shifting even now. And the shifts actually are not uniform everywhere. So it might change somewhere, but might change differently in some other location in the state. And there are other unexpected shifts like travel demand management initiatives, economic growth plans, other multimodal projects that may have wider reaching impacts. Things like those that may impact, which is not really in our control. So it's hard to come up on one number and then say that's what we are going to try to hit. So we, from our, as a staff, VDOT, we have recommended to consider a short range of oscillation when we provide recommendations to our executives. So that's what our recommendation is. Next slide, please. So this is the real encouraging part of our effort, that all this work that went behind the model, we find that this has other potential uses. It uses 30 independent variables and kind of gives us results that are pretty close, right? So which is very, very encouraging to us. The model also shows, and this we did through several experimentations, the model also shows sensitivity to local changes in networks. So if a large segment, which was somewhat, it doesn't even need to be very large segments, say 10 mile, which can be considered a fraction when we are considering the entire interstate system in Virginia. When we made some reliability changes to that section, the model was able to understand that and then reflect that in its prediction of the statewide reliability. So that's very encouraging news that the model is sensitive enough. Next slide, please. So pulling us back a little bit, because we did this effort keeping in mind not just what we have to report for MAP 21, but also a larger philosophy of reliability measure for Virginia. So we kind of used this opportunity to kind of look at what Virginia needs in terms of reliability measures. So this is what we need. We should be able to compare improvement alternatives, capture benefits of traffic management. It should be sensitive to various investment strategies, and assess the system performance in Virginia. The way at the aggregation level that we think is valuable and important, not just as one statewide. Next slide, please. So I know this is a controversial slide and I'm making myself very unpopular, but this is to say why Virginia is the way MAP 21 reliability measure is currently, Virginia is unable to use that for these reasons. It's a large time periods, like 4, 6, and 10 hours. It masks hourly reliability fluctuations. And a lot of our projects are kind of targeted towards that because that's the need from the public. Then we have 1 calendar year span that masks seasonal variations. So Virginia is a very diverse state, and we have locations which are very summer friendly, beaches, and then those which has very heavily influenced by snow and winter. So this entire year kind of masks all those variations. Then the LHCR metric, and I don't want to go over that again, kind of may not always be appropriate because of the unique congestion characteristics that I demonstrated on I-66 example. But next slide, please. This is how this MAP 21 entire reliability measure reporting and target setting helped Virginia. It aided in institutionalizing reliability as a required performance measure in Virginia, which is very helpful to us. It helped move the story from managing congestion all the time to managing reliability. So that is also very helpful, especially when we are targeting operations improvement projects like various active traffic management projects. Then setting targets, of course, we all know that it helps in accountability and achieving goals. And while we are attempting to do that, we went into preparing this model, looking at data, we can use this prepared data and model for Virginia specific measures and then test other potential metrics. Like Simona mentioned, a lot of time the analysts spend, we spend, is kind of trying to clean the data and then kind of gather and clean and kind of overlay, do all of that. So all of that, a lot of the bulk of the brand work we did. So it kind of now helps us think more strategically for the measures that would be very useful for Virginia. With that, that's the last slide. Next slide, please. Yeah, so this is the last slide. There are a lot of people that helped us think through this process, told us kind of when we were going into a lot of the very, very detailed weeds, kind of pulled us back, helped us think through, and then these are all of them. Questions?
Thank you, Sanhita and Simona. Before we get to questions in the chat, we do have one hand raised. Eric, you have your ability to unmute yourself and speak. Okay, if you have any trouble unmuting yourself, you can put your question in the chat, or if your question was answered throughout the presentation, that's fine too. We do have a question from Clint Beck. This was slide 22 for the VDOT presentation, saying that pre-COVID seemed to be around 83%, but it looks like the 86% baseline from 2021 was used from predicting future targets. Any concerns that future years will return to the 83% level?
Yes, always concerns. We are analysts. We are always concerned that things will not go well. But jokes aside, yes, it can. We don't know at this pandemic level that what it will return back to. We also have other projects that are getting completed because during the pandemic, that's the thing that we could do is take advantage of low traffic on the roadway and try to finish some of our projects. So some of the things that happens after a project gets completed, we kind of start to see some of those results maybe 1 year after the project gets completed. So some of these things, there will be a complex, I guess, conditions, like travel time also shifts. So while AM used to be quite significant, we have been tracking the volume trends, and we have found that the AM actually has gone down a bit in some areas, whereas midday actually has picked up. And one of the things that we also found that was in the slide where Simona was showing some of these variables that were significant or not, we found there that midday actually turns out to be a big influencer. So if midday traffic now picks up, then we might have more unpredictability. The short answer is yes, we are concerned, but frankly, at this time, we don't know how else to address that other than trying this machine learning model and taking into consideration all these different variables. Simona, you would like to add something?
I think no, I think what you said is really accurate, Sanhita. So we're always thinking about these things, but at this point, that is the best that we can come up with. And we've seen a lot of positive influence on reliability from these projects. And given the fact that we have these operational improvement projects in the areas where we know we have our reliability issues in the large urban areas, those would be hopefully having a positive impact on reliability, not in just showing in the prediction, but also in real life.
Thank you. I have a comment from Keith Miller, and then I have a question for Iowa DOT. Keith making the comment that reliability is not the same as congestion and separate measures for traffic congestion, and that there can be congested segments that are reliably congested, which is true. We sometimes talk about something being like a reliably bad trip, right? I just want to put a plug in for the congestion measures workshop, which is next week on June 16th. And I believe Sarah or Haley will be putting the registration for that in the chat for those of you who are interested. And then there's a question for Andrea. It says, your original hypothesis was that month-to-month variability was a good surrogate for year-to-year variability in the reliability measures, given that there were not sufficient years to estimate year-to-year variability. Based on your experience now, particularly with what happened in 2019, does that hypothesis still stand?
Yeah, so I think from a visual observation, when you looked at those charts that I showed earlier, there's obviously quite a bit more variability on a monthly basis than the year-to-year numbers. In terms of statistically looking at that, I am not the person who looked at that, so I'm just going to read a couple sentences from our explanation to answer that question. When we did have the 36 months of data, when we were doing the mid-performance period adjustments, we did look at the annual values to see how likely they would be to come from the distribution of the monthly values. For the interstate and the truck travel time reliability metrics, we did observe that these values were typical of the theoretical distributions, so we didn't find evidence to suggest that there were significant problems with that assumption. With the non-interstate NHS metric, that wasn't quite the case. In that case, looking to see whether the annual values would be likely to have come from the distribution of the monthly values, it was atypical. So what we did was use the same spread or standard deviation as the monthly data, but we substituted the mean of the 3 annual observations, which resulted in a shifted distribution. So that shifted our month, instead of using a monthly mean, which was 94.49%, that shifted us to the annual mean of 96.03% for centering that distribution model for the non-interstate NHS metric. So that's about the best I can answer that question today. Thank you.
Thanks, Andrea. So now we can move to some more general questions for discussion that Haley will pull up. Certainly, if people think of additional questions for Virginia or Iowa presenters and want to pop those in the chat or raise your hand, please do so. And so as these other questions are pulled up, I would like to invite people to raise their hands, to be unmuted, to be a part of this discussion. Is maybe number 2, are there, yes, Sanhita.
Actually, I wanted to kind of acknowledge Keith Miller's comment about reliability is not the same as congestion. Definitely so. From a policymaker's point of view, we have to also manage expectations. So if for reliably congested sections, certainly. So we kind of have to consider both from a policymaker point of view and wearing the performance measure point of view, and we have to come up with something that is realistic. So that's why I kind of mentioned the congestion, because it's kind of, that's something public understands. That's something they want resolved. Reliability is something that we're still trying to kind of teach. And frankly, this MAP 21 performance measure has been very helpful in kind of getting that message out.
Thank you. So for people that are in attendance, do you or your agencies want to use a different method than you're currently using? We had I believe that the majority of the attendees in the poll in question said that they used building off baselines with assumptions, but a lot of interest in some of the other more complex methods. Does anyone want to raise their hand and speak to that? Or if not, maybe we could talk about, and also with Virginia and Iowa, how have you communicated your targets to MPOs, leadership, the public? How have you communicated what reliability means? And do you feel like what you've done has been effective?
I can start and discuss our process, Carrie. With the MPOs, we largely have developed these targets internally with the work group. We have work groups for each of the target sets. With the MPOs, we provide them a set of draft targets. We usually give them a couple weeks to review that and comment. And then if we get any feedback, we incorporate that before we make a final decision. Our MPOs, we have 9 of them. To date, 8 of them have supported the state's targets with the target setting cycle, and then our other MPO has set their own. And they've actually done a lot of really great analysis and reporting for their MPO area. So it's great to see that occurring on the MPO level. With leadership and with the public, and frankly, what we give the MPOs is a memo that I referenced earlier with the website on one of my slides. We just try to develop a pretty simple to understand memo that walks through what our process was and what the outcome was for our targets. And then we've been posting that on our website. In terms of how effective that is, I don't know. We haven't developed dashboards or anything like that. That's certainly something that would be nice to put some effort into, especially now that we're starting to get into the second performance period. We have more of a history to show in addition to what we're setting for targets. So I think that's the direction that we'd like to try to go in the future.
Thanks, that's really helpful.
Hey, Carrie, can the attendees unmute themselves?
Yes, they can.
Just to make sure. Actually, one thing that Mina Lockwood actually is also amongst the attendees. She obviously is instrumental in conveying these targets to the executive. So one of the things that we are having a side chat, and one of the things, and Mina, please feel free to unmute yourself. But one of the things that she brought up was that the requirement that Virginia has was that we have a Conduit Transportation Board that basically are representatives of elected leaders around the state interested in, obviously, transportation. So it is a requirement in Virginia that we have to get our it says only administrator can unmute her. Can somebody unmute Mina Lockwood? So one of the requirements that Virginia has is that we get this target, both methodology and the number, approved by this Conduit Transportation Board. That's why it was very important to us that we made sure that the way we communicated and the methodology that we did was both realistic and kind of didn't boil down to kind of a research exercise. Mina, you would like to add anything?
Cynthia, no, you're doing a great job explaining it, but I just wanted to add about the difficulty that we had, or the challenge, I should say, of making our presentation at the right level for all of our CTB members to understand the whole machine learning. It's a hard concept for anybody. And Cynthia and Simone have done a fantastic job with it, but being able to keep the level of detail so they understood what went into it, but also to have some confidence in it and then in the targets was definitely a challenge. I think that's something that you were asking about on your questions here. We were really pushed by our executives to have a more data-driven decision process. So they wanted this, but yet there's the balance of trying to be able to communicate. And it's like Sahida mentioned, we have to have our targets approved by our board. And certainly they want to understand a little bit about how we did it and, what the factors are that went into it and, how sensitive was it to projects and things like that. So that's definitely a challenge. I think a lot of states and MPOs might choose a simple approach because it's easier to explain, and that's certainly a valid approach.
Thank you, Nina. Any question?
Any other?
I have a question actually. Does any other state have to go through this kind of process that we just now talked about, like get approval from not necessarily like a bigger, larger body? Do you have to do that? Or is it mostly handled just within your analyst and planning office? Anybody knows that? I wonder in your research for the guidebook, whether that is a question that you asked Sunil and Kerry and others.
I'm just reminding everyone, you can unmute yourself to talk. We've been unlocked everybody here. Is there anybody on from Michigan DOT or PennDOT? Just thinking about knowing about what some of what those folks are doing in terms of project prioritization based, or incorporating the reliability measure as part of the project scoring. There is a question about when will the guidebook become available. It is currently, the draft final guidebook is currently being reviewed by the panel. And so we believe that it will be available this fall. And we can, it will be advertised and available, but we can also use the emails from the registrations for these web-based workshops to be able to reach out and let you know when it's available. Do we have any other questions as we're winding down these presentations? Oh, see a hand raised. David Heller, you can go ahead and unmute yourself.
Okay. Sorry, can people hear me?
Yes.
Okay. All right. Well, I guess just, I'm David Howard. I work for a small MPO, the South Jersey Transportation Planning Organization. And I don't have as much specific experience, certainly in this performance measure, or at least as far as setting targets and whatnot. But I was thinking about the challenges and I mean, like that machine learning model, that the machine learning language, and like what Virginia DOT, what you just presented, I think that would be great. And it's obviously very sophisticated, but we're a small MPO. I mean, I hate to keep sort of, this sounds like a cliche or
Okay.
But we're a small MPO.
How does that work?
And
Sure.
oh, can people still hear me?
Yes.
Oh, yeah. So no, we're a small MPO, and I think a lot of that would, involve maybe, one or two full-time people where this is just, this is all that, they do for, maybe a good part of the year or, at least several months. So I think there's some staffing, resources. And also looked very time consuming, like you collected a lot of data, like the other independent variables that you collected, for this particular measure. So I think that's one thing. And also to your other point, the ease of communication, I think that is a good point, because we don't have like a board that's, they approve our targets, but I think, they pretty much, I think most of the time, they'll want the 5-minute, sort of elevator, high level speech, high level talk. If I get into the weeds, it's, it can get a little, they're pretty much not, they might be interested, but they don't have the time for it. So I think that ease of communication is a very good point, and something like that, that complex model that, the VA dot is using, might be a little bit involved. So that's just a few of the challenges I think we're facing right now. But overall, I think it was an excellent, a lot of good information. So thank you.
Thank you. Do we have any other questions or comments? Well, with that, I would just like to thank our presenters. There's a lot of good information. We've collected a great deal of information throughout this research project on the various methods for target setting. And I think the guidebook will be useful in that it helps people kind of right size, pick the right method for setting targets that is in line with their staff capabilities, availability of data, and things like that. And so we're looking forward to providing this resource. As to the copy of the slides, the whole program will be, this whole program has been recorded and it will be posted. We believe it will be on FHWA's TPM website. More to come on that, and we'll be able to make an announcement to the registrants as to when these are available. So with that, I'd like to thank everyone for your time, and this concludes the web-based workshop.